In this video, I will go over the homework that follows the lecture 5.2, focusing on doing calculus with hyperbolic and inverse hyperbolic functions, and in particular, we will focus on differentiation in lesson 5.2, and the homework will have two parts, one for hyperbolic and one for the inverse hyperbolic functions. So let's go ahead and get started with hyperbolic functions, and here's what the homework looks like. So problem number 1, find the derivative of the following functions. So we have hyperbolic cosine raised to the power 3, and we have a polynomial inside. So to find its derivative, we're going to recognize the composition of functions. So first we have polynomial, then we have hyperbolic cosine, and then we have the power function. So to apply the chain rule, we start with the most outer function, which is raising to the power 3. So it's going to be 3x squared, but instead of x, I'm going to plug in the hyperbolic cosine with all of its inputs. Now, this gets multiplied by the derivative of hyperbolic cosine, and the derivative of hyperbolic cosine we learned in this lecture, and it's somewhere here. So as you can see, the derivative of hyperbolic cosine is hyperbolic sine. So we're going to multiply by the hyperbolic sine, but we're going to keep that polynomial as the input. And in the last step of the chain rule, we're going to multiply everything by the derivative of the most inner function, which is a polynomial. So it's going to be 1 plus 36x squared. So this is just a simple application of the chain rule. Now to the typing. We have 3 hyperbolic cosine squared of x plus 12x cubed. I'm going to copy this, times hyperbolic sine of the same input times 1 plus 36x squared. And that seems to be it. Submit. And of course we got it right. So the next problem, we have hyperbolic cosecant. So as long as we know the derivative of hyperbolic cosecant, we should be fine. So derivative of f will be 4 times hyperbolic cosecant cubed. That's us applying the power rule to the outermost function. Then we multiply by the derivative of cosecant, hyperbolic cosecant, which is right over here. It's negative cosecant cotangent, so I'm going to multiply by negative 1 cosecant of x plus 3x cubed cotangent of x plus 3x cubed, and multiply by the derivative of x plus 3x cubed, which is 1 plus 9x squared. So that's the answer. Let's start typing it. So here we can bring the negative to the front as negative 4. We can combine the cosecant, hyperbolic cosecant, instead of power 3 and then typing power 1, we can just combine it into power 4. Here we have x plus 3x cubed. I'm going to copy this because we now have hyperbolic cotangent of that times 1 plus times 1 plus 9x squared. We have hyperbolic tangent. Raised to the power 5 of x plus 3x cubed. So derivative of f will be the power 5 goes to the front. We have hyperbolic tangent raised to the power 4. All the inputs are the same. Now we multiply by the derivative of hyperbolic tangent. Derivative of hyperbolic tangent is looks like it's hyperbolic secant squared. And finally we multiply by the derivative of that innermost polynomial function. So let's start typing the answer. 5 times hyperbolic tangent to the power 4 times hyperbolic secant squared times 1 plus 9x squared. All right, and next problem. And the derivative is, again, applying the power rule. Now we're going to follow up with the derivative of cosecant, hyperbolic cosecant. Derivative of hyperbolic cosecant is negative cosecant cotangent. And we're going to finish it with the derivative of the innermost function. So 5 times 13 is 65, x to the power 4. So just like before, we can combine these powers of cosecant and bring the negative 1 to the front. So the final answer is negative 5 hyperbolic cosecant raised to the power 5 of x plus 13x to the power 5 times hyperbolic cotangent with the same input times the derivative of that input, so it's 1 plus 65x to the power 4. And let's just throw an extra multiplication here. All right, so this is the end of the first part of the homework when we practiced the derivatives of hyperbolic functions. Now let's practice the derivatives of inverse hyperbolic functions. So the next problem will be finding the derivative of cosecant inverse. And you probably want to have all those derivatives handy and accessible to you, so you don't have to go back and forward. I don't have them handy, so I'm going to go back and forward here. So what's the derivative of cosecant inverse? It's somewhere here. Let's see. So that's the derivative of hyperbolic arcsecant, right? So there's a typo here. There's a missing h, but here's the answer. So it's going to be negative 1 over absolute value of 3x times square root of 1 plus 3x squared. And by the chain rule, we multiply by the derivative of 3x, which is 3. So this 3 and this 3 cancel. So the final answer will be negative 1 divided by absolute value of x times the square root of 1 plus 9x squared. All right, let's do cotangent inverse. So the derivative of cotangent inverse is something I have to look up. So here it is. Oh, that one's easy. So it's just 1 over 1 minus 13x squared. And there are some restrictions on the domain here, but I don't think we have to worry about it when we're differentiating. But technically, this only makes sense when absolute value of 13x is greater than 1. But we're actually not done yet, because we have to multiply this by the derivative of 13x, which is just 13. So we're ready to type the answer. It's going to be 13 divided by 1 minus 169x squared. We have hyperbolic inverse cosine, but hopefully by now you get the idea. So as long as you know the derivative of hyperbolic cosine, the rest will just be the cosine inverse. The rest is just the application of the chain rule. So the derivative of here's the derivative, and we're just going to apply it. It's going to be 1 over square root of 14x squared minus 1 times 14. And again, this only makes sense when 14x is greater than 1, which we're not concerned with at this moment. So let's just type up the answer. We got 14 divided by square root of 14 squared, which is 196, x squared minus 1. Derivative of this function is the derivative of cotangent inverse times derivative of 3x, which is just this. So the answer is and it looks like we are done practicing the derivatives of hyperbolic and inverse hyperbolic functions. So if you have any questions, please feel free to reach out.